Okay, draw the graph of the inverse of the function whose partial graph is shown on the grid. I'm going to do this two ways. I'll do it algebraically for you, and then I'll do it again using a nice shortcut, and it will be pleasing to see that they both give the same result. At least I hope they give the same result. First one is I need to get an equation for this line. Luckily, they've given us nice numbers to work with. This line has a y-intercept at 4, so it's y equals something x plus 4. And its slope is, it goes down 4 units over 2 units. So a rise of minus 4 over a run of 2 means its slope is negative 2. So this line is y equals minus 2x plus 4. Now that we have that, we can find the inverse with the usual drill where we switch x and y. X equals minus 2y plus 4. That's the inverse. And now to make it nicer, we solve it for y. So take that 4 over to the other side. Minus 2y equals x minus 4. Divide by negative 2. Y equals minus 1/2 x plus 2. And there, algebraically, is our inverse. If we draw this, we should find that it has a y-intercept of 2. There we go. And then for its slope, it goes down 1, right 2. So down 1, right 2. There's another point. Down 1, right 2. There's another point. Grab a straight edge and connect those points. And there we go. There's our inverse. The other option, which is maybe a little less rigorous, but it's certainly easier, is take some points off the original function. That's a nice one too. Okay, so our original function had points like, I'll do this down here because I need a little space. The original function had 0, 4. It had 2, 0. And over here it had 4, negative 4. You remember how when we're doing an inverse, we switch the positions of x and y? Guess what? That works with points too. If you want to find what the inverse is up to, just take points that are on the original function and switch the x and y. So if the original went through 0, 4, the inverse is going to go through 4, 0. If the original went through 2, 0, the inverse will go through 0, 2. You just swap their positions. And if the original went through 4, negative 4, then the inverse will go through negative 4, 4. Let's see if that worked. The inverse goes through 4, 0. 1, 2, 3, 4. Yeah, that agrees with what... Sorry, I'll use something reddish for this. That agrees with what I got algebraically. 0, 2. Yeah, that agrees with what we got algebraically. And negative 4, 4. 1, 2, 3, 4, 1, 2, 3. Nice. Love it when a plan comes together. So, the trickier the expression is, probably the more you will want to do it algebraically, because then you get a very precise equation and you can plot all the points you need off of it. But if the thing is really annoying and you can't figure out its inverse, if this is just too hard to do or whatever, swapping points like this is totally effective and quite a bit easier. Now, let's see what else they have for us here. The function passes through the points 10, 16 and negative 10, 24. Write the coordinates of 2 points which must lie on the graph of the inverse. Well, I've kind of ruined the surprise here by telling you this already. That's just 2 more points they want us to swap. So they say if our original function went through 10, negative 16 and negative 10, 24, then the inverse would go through what? You swap these, it should go through negative 16, 10, and it should go through 24, negative 10. Just a quick point, just pretend this isn't true for this function, but if your function went through, let's say, 8, 8, then the inverse will go through the exact same point. Sometimes a function and its inverse have points in common, and this is one of those times. When the x and y are the same number, then you switch their positions and you can't tell the difference afterwards. that's when you get a function and its inverse going through the exact same spot. It does happen. Okay, they say the equation of the function is y equals 4 minus 2x. No kidding, we knew that several minutes ago. Determine the equation of the inverse of the function. Okay, well, I apologize. It looks like I did this question out of order. But we found the inverse of the function already, and you've seen what the drill is. You switch the positions of x and y, and then you solve the result for y. So the answer again for the inverse, f inverse of x, is minus 1/2 x plus 2.